Hi everyone. Today we're going to review the trig ratios. You can find this document on PowerSchool so you could download it or print it out. So let's get started. For a right triangle, the sine, cosine, and tangent of an angle theta is defined by sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. And then to remember these, remember SOHCAHTOA. SOHCAHTOA. Okay, that'll help you memorize these ratios. So in example one, we're going to find the sine, cosine, and tangent of both angle A and B. But before that, we need to find the hypotenuse. A quick way to find the hypotenuse is with the Pythagorean theorem, because we still are working with right triangles. So 15 squared plus 8 squared is equal to AB squared. So we'll use the calculator for this. So 289 is equal to AB squared. And if I find the square root of that, 17. So AB is equal to 17. Awesome. So now I could fill these in. So here's A here. If I'm working with A, 8 is the opposite number, opposite side, 15 is adjacent, and 17 is the hypotenuse. So opposite of over hypotenuse is going to be 8 over 17. The cosine of A, adjacent is 15, hypotenuse 17. Tangent of A, opposite is 8, adjacent is 15. Okay. Now, the sine, cosine, and tangent of B are going to be different because now we're at a different angle. We're at this angle over here. So I'm going to write this in blue. For angle B, 15 is the opposite side. 8 is the adjacent side. 17 is still the hypotenuse. That stays the same. So the sine of B is 15 over 17. The cosine is adjacent 8 over hypotenuse 17. And the tangent is opposite 15 over adjacent 8. They are slightly different, okay? Depending on which angle you're using. So I have some examples here. We're going to find the missing sides. Okay. So to find the missing sides, you're going to need a trig ratio and at least one other side. And we have a reference angle here. We're going to use the 70-degree angle. So first of all, you have to determine what information you're given. 7 is the hypotenuse because it's opposite to the right angle. And x is going to be opposite to the 70-degree angle. So the trig ratio that uses hypotenuse and opposite is going to be the sine. So let's set up our equation. So the sine of 70 is equal to x over 7. To solve this, we're going to cross multiply. So I'll put the sine of 70 over 1. So we have x equals 7 times sine of 70. Remember, do not multiply the number inside the trig ratio with the number in your equation. That's not allowed. First, you multiply 7 times the sine of 70, because sine of 70 is its own number. Let's 7 sine 70. So x is approximately 6.6. Doesn't say how to round. So for this worksheet, is just round to the 10th place. So 1 decimal point. All right, number 2. You have the opposite of the 65-degree angle, and you have the hypotenuse. Okay, so once again, we're going to use sine. So the sine of 65 is equal to 10 over x. Okay, we're going to cross multiply again to solve. Okay, but this time we're going to get x times the sine of 65 equals 10. So we still need to get the x by itself. So this has an extra step. You have to divide both sides by the sine of 65. Okay, so this goes away here. So x equals, let's use our calculator, 10 divided by the sine of 65. That is 11.0. So that rounds down to 11.0. Let's move along. Okay, here we're given this 24-degree angle, 4 is the opposite, x is the hypotenuse. So once again, we're going to use sine. So the sine of 24 is equal to 4 over x. We're going to cross multiply first. So x sine 24 is equal to 4. Divide both sides by the sine of 24. So x is equal to 1.6. 1.6. And number 4. Okay, we have this 55-degree angle. 20 is the hypotenuse. X is adjacent. So the trig ratio that uses adjacent and hypotenuse is the cosine. So for this one, cosine of 55 is equal to x over 20, adjacent over hypotenuse. We're going to cross multiply. So x is equal to 20 times the cosine of 55. Using a calculator, that is 1.1. Example 3. So now we're going to go into finding the missing angles. So to find a missing angle in a right triangle, we must use inverse trigonometry. Okay. So here's an example here. If you have the sine of an angle, which is equal to a value, then the sine inverse of that value is going to give you the angle. So if the sine of 30 degrees is 0.5, then the sine inverse of 0.5 is going to be 30 degrees. You can check that with the calculator. So the sine of 30 is 1/2 or 0.5, and the inverse of 0.5 the sine inverse of 0.5 gives you the 30-degree angle. Okay, so we're going to apply these with these examples here. Once again, use the information that's given to determine which trig ratio you're going to use. All right, so the angle of interest is here. 6 is adjacent, 8 is the hypotenuse. So the trig ratio that we're going to use is going to be the cosine. So the cosine of that angle is 6 over 8. So the cosine inverse of 6 over 8 will give us the angle. So let's go to the calculator. 6 divided by 8 is 41.4 degrees. Okay. Number 2. 5 is the hypotenuse. 4 is adjacent to the angle. So once again, we're going to use cosine. So the cosine of the angle is 4 over 5. So the cosine inverse of 4 over 5 is going to give us the angle. Approximately 36.9 degrees. Okay, number 3. Notice in number 3, you're given all 3 sides. So you can use any of the three trig ratios to find it. Just use the appropriate size. So 50 is the hypotenuse, 48 is adjacent, and 14 is opposite. Let's say we use tangent for this one. So the tangent is opposite over adjacent. In this case, it's 14 over 48. So the tan inverse of 14 over 48 will give us the angle. And that's 16.3 degrees. It's a pretty small angle, so it looks like these drawings are drawn to scale, but don't assume. I did say you could use any trig ratio, so let me show you what happens if I use the cosine. So I'm just going to use the calculators to follow along. So the cosine would be adjacent over hypotenuse, or 48 over 50. Notice that you still get the same angle in the calculator. Or if I use the sine of that angle, it's going to be 14 over 50. And you still get the same angle. Okay? All right, so number 4, we could use any ratio because we have all 3 sides. So I'm going to use the cosine this time. So the cosine is adjacent over hypotenuse, 30 over 34. So the cosine inverse of 30 over 34 is 28.1. And last one, I use the sine for this one. So the sine of the angle is opposite 68 over hypotenuse 85. So the sine inverse is 68 over 85. That is going to be 53.1 degrees. Okay, that is all for today. Your homework is going to be to finish this document So it's going to be the practice 1 through 15. There's a few word problems in there. All right. I hope you enjoy the rest of your day. Goodbye for now.